Today, we're going to demonstrate the techniques required to bond a strain gauge to a rough surface like cast iron or a porous surface like concrete or something like that. The first step, because this cast iron is a cured or treated cast iron, we need to degrease it. I'm going to use the CSM3, spray it directly into the gauze sponge, and then wipe the area where the gauge is going to be installed. You'll note we've masked it off so that when we grip blast, after we do this degrease, it will limit the grip blast. Note the amount of dirt and debris that came off. Next step, we'll do the grip blast. Notice the grip blast removed the black oxide material, the pre-cure for the coating, leaving it pretty much clean surface. After the grip blast, you'll notice that the cast iron, which used to be black with a coating, is now the natural gray color, removing all the surface oxidization and preparing it for the bonding of the gauge. The next step in the surface preparation of our cast iron skillet is to use Conditioner A mild phosphoric acid solution to scrub the surface, removing the leftover organic materials and any dust or debris that might have been left behind by the grip blast. Taking a cotton tip applicator, I'm going to scrub the surface of this part. Notice it comes up slightly gray. It's etching the surface. I'll take a gauze sponge, fold it into quarters, and I will dry the surface, removing the excess moisture. Now that the Conditioner A has done its job, we're going to use the Neutralizer 5A, the Bo Peep ammonia solution, to bring the pH down to up to a nominal neutral or slightly basic. Most of the adhesive systems do not like an acidic condition. So I'm going to take the blue tip bottle, the Neutralizer 5A, and I'm going to scrub the surface with the neutralizer. Notice I'm preparing an area much larger than where the gauge is actually going to land, because I want to make sure that I got the area thoroughly cleaned and none of the contaminants leach into the gauge site.
Do we need to wait a certain amount of time after removing the excess neutralizer before we can apply the M-Bond AE10?
The waiting time, you want to be between 10 minutes and 30 minutes between the time you finish your surface preparation and the final application of the adhesive. Oxidation begins to occur almost immediately after the cast iron has been exposed to the air, and so we want to limit that amount of time. Take a gauze sponge, a dry gauze sponge, fold it into quarters, and I'll dry the surface of the beam. Because it is a cast surface and it's potentially going to contain some of the moisture in the pores of the surface, I'll use a heat gun and I'll drive off the excess moisture, the leftover Neutralizer 5A. With the surface thoroughly dried, we'll now mix our AE10 and put down a pre-coat. Because of the roughness of the surface, the strain gauge does not tolerate that roughness very well, so we want to do a pre-coat and then abrade back till we just expose the surface underneath. With our surface preparation complete, we now need to mix the AE10 resin with the proper amount of AE10 type 10 curing agent. We have a pipette, and the Mark 10 is what we're going to be using. First thing you do is open up and remove or discard the cap from the AE10 resin. You don't want to put that back on. Remembering that the AE10 curing agent is very hygroscopic, we want to limit the amount of time that it's exposed to the air. So I'm going to open the AE10 curing agent, draw the right amount up into the pipette, dispense that into the center of the jar, recap the curing agent, making sure it does not get too much moisture contamination, and then I'm going to stir the AE10.
Tom, how long are you going to stir it for?
Well, it takes a minimum of 5 minutes of stirring, and if we're going to use this material at its minimum air cure time and temperature, we would allow it to sit and ingest or kick over the reaction for another 5 minutes. So I'm going to mix this for 5 long minutes.
Now, Tom, why are you holding it by the neck of the bottle rather than cupping it in your hand or something?
Because this adhesive system is an exothermic reaction, I want to limit the amount of heat that I'm adding to it because it'll kick it over prematurely. We only have a 15 to 20 minute pot life to use this material, and so I don't want to shorten that by grabbing it like this and making it hot. I always grab it by the rim of the jar.
Well, Tom, I'm also noticing some bubbles in the adhesive, and air pockets underneath your strain gauge are dangerous, so...
Might be very difficult for you to see in the camera here, but we are entraining some air into the adhesive system while we're mixing it. But Matt, that's not going to be a problem. When we put the proper amount of clamping pressure on the adhesive, it will squeeze out all that excess air that would be trapped under the gauge. No, nothing to worry about.
Thanks.
With the mixing of the AE10 complete, we now need to clean off the stirring rod. We don't want any partially mixed adhesive or resin or curing agent on the stirring rod, so we clean that off. Then I dip down in the center of the jar, and then I just wipe the adhesive. I'm pre-coating. We're filling up the pores of the surface of the cast iron. And you'll notice I'm being kind of liberal with the adhesive because I'd rather have too much than too little. And while the gauge is only going to occupy a small part, I'm going to go ahead and pre-coat a fairly large area just to make sure that I cover everything that I want to have pre-coated. Having done that, I very loosely return this PCT 2M tape to the surface. I'm not pushing down at all. All I'm doing here is helping to limit the thickness of the adhesive layer. I don't want to have so much to sand away when it comes time to remove the excess. The AE10 has a pot life of between 15 and 20 minutes. You can extend that by putting it out on a clean or aluminum plate that would cool it, but in this case we don't have to worry about that. Now we're going to wait for this pre-coat to fully cure, which takes a minimum of 6 hours at room temperature, and preferably cure it overnight. Tomorrow we'll come back and we will finish the surface preparation by removing the excess adhesive or the excess pre-coat, and then bond the gauge in place.
Tom, with a small part like this, and if I didn't want to wait overnight, can I stick this in an oven?
Certainly, Matt. This material, if you get the temperature up to around 200 degrees Fahrenheit, the bond line temperature or the adhesive temperature, it'll take about 30 minutes to kick it over.
Excellent.
However, it doesn't ever hurt to go long. If you think it takes 30 minutes to cure it, I'd go 45 minutes to an hour just to be sure that it's fully cured.
Excellent.
So Matt, to recap the steps we've done so far, initially we degreased it with the CSM3, we grit blasted it with the air abrasive, and then we did a pre-coat with the AE10. At this point we have taken this silicon carbide abrasive paper, taped it to this surface, and I've formed this pink pearl eraser to the shape of the part so it clamps evenly. Now we need to remove the excess material from the pre-coat. So we'll take the 220 grit silicon carbide abrasive paper and we'll abrade this until we just begin to expose the parent material underneath it.
So Tom, it looks like we've prepped the surface. What's the next steps from here?
The next step is to prepare the strain gauge for bonding, and we'll have to lay it out on a glass plate. And that glass plate and the blunt nose tweezers have to be chemically clean. So I'm going to take the Neutralizer 5A, the blue tip bottle, put a few drops of Neutralizer 5A on the glass plate, scrub it, take the same gauze sponge that's still damp with the Neutralizer 5A, clean the blunt nose point of the tweezers. We don't want to have any contamination there. We're now going to locate the strain gauge. In this case it's a CEA 06 032 UW. Using my blunt nose tweezers, I'm going to pull that out of the folder. It's in an acetate window. I'm going to splay open that acetate folder, he says with great confidence. Grabbing it by the tab end of the gauge, never grab a gauge by the grid end. I'm going to lay that out generally how it's going to be on the part itself. I'm then going to take the bondable temperature sensor, an ETG 50A, and we're going to bond that next to it because we want to monitor the temperature during this test. Again, using my blunt nose tweezers, I'm going to remove that from the folder. And as I did before, I'm going to grab it at the tab end of the temperature sensor. And I'm going to set those side by side. We're going to use the same piece of tape to transfer these to the pan handle as we had seen before. Take the PCT 2M tape, take about 2 inches off, throw it away. That could be contaminated. Then pull it off about 4 or 5 inches. It's not terribly critical. I'm going to stretch the tape to keep it from curling up so much. I also like to put a pair of handles, one on either end, so that I can easily remove it. I just fold the tape over about 1/4 inch, and that gives me a handle to grab it hold of. I'm then going to place it over the top of both the RTD and the strain gauge. I'm going to lift at a shallow angle. If you lift at a sharp angle, you're going to end up damaging the gauge and the temperature sensor. And then I'm going to position the strain gauge in the middle of that radii that we had planned on before, making sure it's well taped into position. Now I need to prepare the AE10. Just like we did before for the pre-coat, we're going to take the AE10 resin jar, open it, throw away the cap. I'll have the stirring rod at the ready, the type 10 curing agent, remembering that it's very hygroscopic, so we want to limit its exposure to moisture. I'm going to draw up the appropriate amount. Dispense that in the center of the jar. Dispose of the pipette. Immediately recap the curing agent. We don't want to leave that open very long. And then using the plastic stirring rod, I'm going to stir this for 5 full minutes.
Sorry.
Okay, we've finished the mixing of the AE10. Now we need to take the stirring rod, because there might be some unmixed curing agent or resin on it, and clean that. You'll lift up the gauge handling tape so we expose the bonding surface of the gauge.
Again, lifting at a very shallow angle, not to damage the gauge or the RTD. I'll peel it back and hold it in place for Tom to apply adhesive.
Now I'm going to put a small amount of adhesive. It doesn't take a lot. You just need to wet the surface of it. Okay? Put too much and it'll just squeeze out and it'll have a mess around it. Then I'm also going to take a drop of the adhesive, and I usually let 2 drops drop off of it before I start to minimize the adhesive. I'm also going to put that in the target area where the gauge is going to land. This thoroughly wets the surface so we don't have a starved bond line. Notice I'm using the side of the stirring rod as a squeegee. And now we'll return that back into position.
I'm not bearing down as I'm pushing this in place.
Just kind of push it out, and then you kind of wipe away the excess. We've taken this pink pearl eraser and we've formed it to the shape of the radius there so it fits nicely. We're going to put that over the top of the gauge and temperature sensor combination. The aluminum backing plate is to help distribute the load through the pink pearl eraser. I'm going to take a clamp, and this should be applying nominally around 15 psi of clamping pressure. And now we let it sit for a minimum of 6 hours, preferably 24 hours overnight or something like that. It gives you a guaranteed bond. And at this point, we wait.
So Tom, so far it looks like we've prepped the surface, got our gauge bonded yesterday, and let the AE10 cure overnight. Now it looks like it's time to remove the clamps, inspect the gauge, and attach our lead wires.
There you go.
All right.
Let's go ahead and do that. Let's remove the clamps. And we've exposed the surface of the tape. Now, before we lifted the tape at a shallow angle, and this time we're going to pull it 180 degrees back on itself. It gives us the best, puts the adhesive into shear instead of peel, and therefore it survives this event. Okay, and we want to do a quick visual inspection. I would pull out my jeweler's loupe and have a look. Looks like we got a pretty good gauge going on here. So the next step will be to tin the tabs of the gauge. I have a soldering pencil here set up and warmed up. The steps will be to clean the tip, lightly tin the tip, place the solder in the target area, and add fresh solder and flux. This whole operation should take between 1 and 3 seconds. If it's taking longer than that, then there's something wrong with your soldering iron or your technique. Having tinned the tabs, I'm now going to take this lead wire. This one's going to be for the temperature sensor. We're going to put a piece of paper drafting tape just behind where the insulation ends and the conductors begin, and we're going to form the classic cobra head. Okay, put a slight bend in the tape, or the wire, so that when we put this down over the top of the gauge, it holds the gauge in position and preloads the wires so that they're in a downward spike. I'm going to take my pointed tweezers and readjust those so that they're over the top of those two connections. And then I'm going to reflow that junction. Clean the tip, lightly tin the tip, place the solder in the target area, and add fresh solder and flux. And again, this whole operation should take no more than 1 to 3 seconds. Now, I could take this tape up at this point, but I'm going to go ahead and leave it there so that I can do the other, the strain gauge itself, using almost an identical technique. Remembering, this is a strain gauge, and therefore it does not have polarity in the quarter bridge configuration, so it doesn't really matter which side I put the red wire or the black wire on the gauge. However, for continuity, I always put red to the right. So I'm going to position these over the top of the tabs of the gauge. Reposition them with the tweezers so that they're directly over the top. And I haven't put enough bend into it, so it's not going to point down enough. So let me redo that. Now I can position those two wires over the top of those small tabs. I think I'm going to start by positioning the black and white and reflow that one, and then I'll move the red one into position because it's more flexible. Give us an anchor point. Having done that, I'm now going to position the red wire. And then reflow that junction. Having completed those junctions, I'm going to take the rosin solvent. The rosin solvent's going to do two things. It's going to break down the mastic of the paper drafting tape so it doesn't damage the gauge while I'm removing it. And it's also going to begin to break down the flux that was left behind from the soldering operation. Note I'm just going to saturate the whole field with the rosin solvent, covering the tape with it. And I use just the bristles of the brush to remove the paper drafting tape. If you use too much mechanical force, you can damage the strain gauge and or the TG temperature sensor. So I'm just working in and underneath it to get the tape mastic to give up and then slide it out of position. Now I'm going to concentrate on these solder junctions. Having put the flux into suspension, I'm going to fold a gauze sponge into quarters and blot the area dry. What we're doing is putting the flux into suspension and then removing that suspension. And we'll wash it 3 to 5 times. Depending upon the longevity of the application, the more you want to wash it with the flux or the rosin solvent to remove this flux. Looks like we're pretty good there. I'm seeing something here on the edge. I don't want to have it shorting to the part, so I'm going to take that out. Everything else looks good. Now I need to introduce a strain relief loop to both of these wires, just in case somebody steps on our wire. There's a chance we might save the gauge. So I'm going to take my pointed tweezers and a cotton tip applicator handle, and I'll slide that up underneath the lead wire system and then rock away from it. This is a little difficult to do in this position, so I'm going to stand up. The idea is to form a little inchworm shape there. And then I'm going to take a piece of paper drafting tape that will be a permanent piece, as permanent as paper drafting tape can be, and I'll tape it into position. And the last step would be to check it with the GIT 1300. We'd take the GIT 1300, check for installed resistance to the strain gauge, resistance to ground, and all those electrical parameters that would make sure the gauge is electrically properly operational. Having finished the connection of the lead wires and cleaning up the flux, we need to check two things: the resistance tolerance of the installed strain gauge to make sure it's going to balance in our instrument, and also the resistance to ground, which is an indication of how much we've cleaned up the flux. If we left flux behind, that resistance to ground would cause the gauge to drift or be unstable. The GIT 1300 uses 15 volts to check that resistance to ground. It's a battery operated instrument, so the first thing we should check is to make sure the battery's okay. And then we're going to go to the 1% scale. I'm so confident that I'm going to be within the 0.5% tolerance, that go to the 1% scale, and I'm at about 0.18%.
Now, Tom, is it true that if the wire was not soldered correctly, or if we had a damaged part of the wire or such, we'd probably see it there, right?
You would definitely see this, because you'd either be an off-scale negative or off-scale positive, because the resistance would not be appropriate. And the next thing we're going to check is the installed resistance to ground. That is the mega ohms resistance, and in a properly installed strain gauge it should be at least 10K mega ohms resistance to ground or better. And in this case, it's riding up near infinity, so we've done a fairly good job of cleaning up the flux, and we've checked out electrically. Everything's electrically. We have not checked out the gauge mechanically. You can only do that by loading the part. So at this point, we'll disconnect the GIT 1300, and I'll find our environmental protection. We're going to use M code A in this case. It's good to about 200 degrees Fahrenheit, so we should be good for this particular application. And I start in and around the solder junctions first, and then work up underneath the lead wire and around all this to coat the gauge. And environmental protection is important to keep moisture and other mechanical debris and that sort of thing out of the gauge site, because it would cause it to look unstable. Now this has to air dry for about 15 minutes to get the solvents gone, and then full cure is in 24 hours. So tomorrow we'll test. Okay, we finished the installation of our strain gauge on our cast iron frying pan handle, and we're about to prove that the cast iron frying pan handle is fairly sufficiently safe in terms of using it with normal cooking. I'm going to just lift the pan itself, just putting the strain of the dead weight of the pan on it. And you see it's a very small value. Now I'm going to set the pan down, take 4 pounds of bacon, it's really hard bacon, and I'm going to lift the pan again. And the strain level should have increased. Nowhere near the yield point of this cast iron material, and quite safe for kitchen applications.
No, I like to cook 10 pounds of steak at once.
You need a bigger pan. So Matt wanted to put a 10-pound steak in here, so I'm going to pick up our 10-pound steak and put it in the pan and lift it up. Boy, this is a lot heavier than the 4-pound steak. And set it down. Matt, you're cooking the 10-pound steak. I don't want to handle a pan with 10 pounds in it. So now we have the very same frying pan, and we're now going to put it onto a hot plate and see if the strain or the stress changes with temperature. We've set the hot plate to be 350 degrees Fahrenheit. Now it's going to take a few minutes for this to warm up, and we'll look at the change, just at the static change in strain because of temperature, and then we'll also pick it up with the 4 and 10 pound weight. Now the temperature of our handle has now gotten up to about 100 degrees Fahrenheit, 98 among friends. Now let's see if the strain change is going to be different. Now notice we have a thermal output of nominally 140 microstrain. So we'll take that and we'll add this strain to it. We'll go to the 4 pound weight and compare that. And then the 10 pound weight, that big old piece of steak that Matt wanted to have. So it appears, based on our numbers, that we didn't have a very large change in strain based on the fact that it's gotten warmer. So it tells us this cast iron frying pan, even though you're getting up into the 150-200 degree range, is not going to change strain very much. You've still got a very safe pan.